Hello everyone, this is Miss Chelsea and today we will be learning about average atomic mass. Our question of the day is, why is the average atomic mass not a whole number? Our current standard is SC1D. Construct an explanation that relates the relative abundance of isotopes of a particular element to the atomic mass of the element. In the real world, we can have multiple isotopes of one element, and all of those isotopes will not have equal abundance. They will not be equally popular. Because some are more popular, we need to calculate the average a bit differently than what you're used to. The number on the periodic table, the average atomic mass, is actually the weighted average of all the naturally occurring isotopes of an element. This is why the masses on the periodic table are not whole numbers and instead have a decimal. Remember, in math, a weighted average is an average where the components are not weighted equally. You can think of this as grades in a traditional school. So, for example, if you have a test average of 92 and it's worth 50% of your grade, a homework average of 70 worth 30% of your grade, and a lab average of 80 worth 20% of your grade, you would need to figure out which will have the greatest effect on your overall grades. Well, in this case, the one with the highest worth, the test. As tests are worth the largest portion of your grade, your overall grade will be largely dictated by the test category average. However, the homework average and lab average will have some effect on the overall average. To figure out how much of an effect, we take the amount times the value as a percent. So 92 times 50, 70 times 30, and 80 times 20. We then add these all together to get a total and then divide by 100 since we're looking at percent. In this case, when you type everything into your calculator, you get 83. Notice how this is higher than the homework average and the lab average. That's because they're worth less than the test average, which is higher here. Let's try an example. What is the average atomic mass of neon based on the data table showing its naturally occurring isotopes? So notice how we have three isotopes, neon 20, neon 21, and neon 22, with neon 20 having by far the highest abundance. Let's go ahead and multiply each isotope's mass by its abundance. We can then add all of these together to get the abundance of all the isotopes and then divide by 100 to get the number without dealing with percents. This means that the average atomic mass of neon will be 20.179 AMUs. So go ahead and try the show what you know questions before you check your answers.